So this video is just the video over STAAR questions students have sent me this weekend while they've been studying, even though I said to only study for at least an hour between Saturday and Sunday and not to overstudy. But just to go over a few of the common questions that you might see, I'm going to pull some questions from last year's STAAR and explain how I would work them out if I was taking the test. So one question I received was from someone asking me for keywords. So I'm going to try to hit that every time I go through a question, looking for those keywords that could be helpful. So the first question, pulled this from the STAAR last year, says the baby weighed 7 2/25 pounds at birth. At the end of 8 months, the baby weighed 2.5 times its birth weight. How many pounds did the baby weigh at the end of 8 months? So once again, like in my strategies, I say read it twice. The baby weighed 7 2/25 pounds at birth. That's important. And the first thing I look at my answers and I kind of skim through them. Is there any that's less than that? Because the baby would be growing and none of them are less. So we're going to keep going. At the end of 8 months, the baby weighed 2.5 times. So I know times is a keyword. It means to multiply. Its birth weight, and then it just wants to know how many pounds did the baby weigh at the end of 8 months. So the first thing I would do is eliminate silly answers. So first off, 2.5 is more than 2. And I have 7 2/25 already. So I know that 7 times 2 is 14. So this has to be more than 14 pounds. And I already see an answer I can eliminate. So G can be an automatic eliminate because it's not more than 14 pounds. So the next thing I'm going to do is now I'm actually going to start working the problem. So I notice that one is in fraction and one is in decimal. So what I suggest doing is putting them both in whatever the answers are. So if you notice, all of our answers are in decimal form, so I would change your answer to decimal. So you should know that a half is 5/10. If you don't know, just do the division. Remember, numerator on the inside. Add your decimal. 2 goes into 10 5 times. Okay, so then we can multiply that. Do 7 2/25 times 2 and 5/10. And notice your decimals do not need to be lined up when you're multiplying. So 5 times 5 is 25. 5 times 2 is 10 plus that 2 on top is 12. Carry the 1. 5 times 7 is 35 plus the 1 on top is 36. And then I like to mark these out so I know I use them. Then don't forget that placeholder. That plays a big role. 2 times 5 is 10. Now this becomes a 1. 2 times 2 is 4 plus that 1 is 5. 2 times 7 is 14. So I have 5, 2, 11, 8. And then you always have to go back and count how many decimals do I have? 1, 2, 3. Which actually you don't really have to. You can quickly see there. Also, what you could have also noticed is if you had this as what you were going to multiply to, you have 1, 2, 3 decimal places. There is not 3 decimal places here, so that could have been an elimination. So I know most of you have seen this problem before because we've gone over it, but I want to go over it again about writing your ratios. So remember, when they're comparing two different things, that's a ratio. A barrel contains 60 gallons of water. So I would underline that. Water leaked out of the barrel of 5 gallons every 3 days. That's a ratio. 5 gallons to every 3 days. Okay, at this rate, how many days did it take for all 60 gallons of water to leak out of the barrel? Okay, so once again, you read the question again, go back and underline all that important things because it's very important. Set up your ratio. So you have 5 gallons to 3 days equals, well, we need to figure out 60 gallons and how many days that would take. So we have to notice, how do I get from 5 to 60? Well, that is times 12. And that's where this answer comes in right here. But you should think, well, we have not multiplied the bottom to get to 12. So then you times this by 12, which is 36 days. 100 days is one of those, that should have been your throw out. That was a silly answer. Also, if you didn't remember to write a ratio, work it out. 5 gallons, 3 days. 5 gallons, 3 days. 5 gallons, 3 days. Add that up. This would be 20, and this would be 12. So clearly it can't be 12 days because that was only 20 gallons. And then you could keep adding to that until you got to 60 gallons if you didn't remember how to set up your ratio. There are more than one way to solve a problem. Okay, so this is a model question. When you're looking at the model, make sure you understand what the model represents. So in this one, it says the shaded model represents 100%. This bar right here is 100%. So the first thing I notice is that this is an entire bar, so that's 100%. This is an entire bar, that's 100%. This is an entire bar, that's 100%. So this is already at 300% when it says they want the model that represents 33 and 1/3%. So that's a throw out. That makes no sense. Then on this one we have 100% here, another 100% here, another 100% here, because every bar that's filled in represents 100%. So this one already has 300%, which is throw out. So now we are down to two different things. So first thing is anytime you have a model and it's split up, it can be a fraction. So I can represent this fraction as 1/3, and this fraction, so there's 1, 2, 3, 4, 7, 8, 9, 10, and this would be 3/10. Well, this is easy. We can make 3/10 into a percent, because remember we've talked about part over whole equals percent over 100. So I need to figure out, how do I get to 100? Well, 10 times 10. So this would be 30 times 10. So this one's 30%, and that is not what they want. So even without finding out that 1/3 is 33 and 1/3%, you can still solve it. But just in case, check your answer. Remember, numerator goes on the inside. Okay, so your 1 goes on the inside, 3 goes on the out. Just add your decimal. 3 cannot go into 1, but 3 can go into 10 3 times. You get a 9. Oh, look, you're getting a 0 again. 3, 9. And you can tell now, okay, this would be, then you would move your decimal twice. So you would have 1/3 left over. So C is the right answer. Let's look at this next problem. So this, you can automatically see, okay, it's already fractions. So visualize in your head what this would look like as fractions. A recipe for cookies requires 2/3 a cup of butter. That's important, underline that. Rama wants to make 3/4 of the recipe. So here's my first question. If she's only making 3/4 of the recipe, does she need more than 2/3 of a cup? No, she doesn't. So I can eliminate any that are more than 2/3 of a cup. So 1 5/12, that's an eliminate, because she's only making 3/4. So it's like one recipe is equal to 2/3 of a cup, but she's not even making a whole recipe. And then if you notice, 2/3 of a cup is only a little more, is close to a whole, so it can't be 8/9 either, because 8/9 is closer to a whole. It's more than 2/3. So now let's go back to looking for those key words that the student asked me to find. A recipe for cookies requires 2/3 cup of butter. Rama wants to make 3/4 of. Anytime you see that word of with fractions, it normally means to multiply. And I want to say that with fractions, keyword there. So you would take 2/3 and times this by 3/4. And so I would get 6/12. Oh my goodness. That's not an answer choice. That would be some of the first things people would think, not an answer choice. But remember, look if they can be simplified. Yes, 6 can go into both of these. So divided by 6, and you'll get 1.5. And look, J is the answer. 1/12 can also pretty much be thrown away because that's like no butter at all. And she's making 3/4, so it needs to be closer. So see how a lot of these problems, if you just think about what the answer should be, then sometimes you can eliminate several answer choices. Okay, so the next question says, which two expressions are equivalent? So we have to remember equivalent has the word equal in it, so it means which two are equal. So in this one, you can't actually solve these because we don't know what y is, but you actually could if you wanted to. So if you're not 100% sure and you're stuck on a problem, plug a number in. The only number you cannot plug in, well, two numbers, is 0 and 1 because that will change things. So I suggest use the number 2. 2 is the easy number. So think about if I plugged in 2 here and 2 here. If I work these out, would I get the same answer? So 4 plus 3 times 2 is 6. This makes 10. Remember, this is a PEMDAS problem because there's more than just adding or subtracting. There's more operations going on. So then this one has parentheses, so 7 times 2, well, that's 14. So those are not the same, so you can automatically cross that out. So now plug in 2 here. So 18 divided by 2 is 9, plus the 10 is 19. But if I plug it in here, this would be 10 plus 2 divided by 18, which is 2/18, which is not, that'll give me 10 and 2/18. 2 divided by 18 is not 9, because remember, when you see this, this means the 2 goes on the inside and the 18 is on the out. So add that decimal, it'll go in there once, subtract, and it's just going to keep repeating, etc. So nope, can't be B. Next, we have 12 minus, once again, we're plugging 2 in here. 2 times 2 is 4. Okay, that makes 8. So you're going to plug 2 in here. 12, 2 times 2 is 4. Oh, that makes 8. So we're going to put a question mark by that and come back to it. Let's check the other ones just in case. So remember, you're going to plug a 2 in there. 10 minus 6 is 4. Divided by 2 is 2. 10 minus, this becomes 2. 3 is 7. So C is the only one that makes sense. So if they give you something like this, choose a number that's easy to work with and plug it in. As you can see, I chose 2 because multiplying by 2 is super easy. Okay, I love tables, graphs, equations. I find them so fun because they pretty much tell you the answer, which is cool, and you can test it. So let's read this question. The table shows the relationship between D, the amount of money Alice has at the beginning of each day, and W, the amount of money she has after riding the bus to work. So here's my D, here's my W, before and after. Okay, which equation represents the relationship? So the first thing I would do is I would look, what is happening from the left side of the table to the right side of the table? Well, the first thing I notice, it's going down. It's not going up, it's going down. So you should automatically be able to eliminate 2 possible choices that show that going from D days to W is going down. I mean, they're going up because in the problem it's not. So right here, if you add $1.25 to this, it's not going to go down. So F is eliminate. It's a stupid answer. Also, multiplying and then adding, you're like way adding to that. So it can't be G. Look, we've already went down to a 50-50 shot just by knowing that this is going down. So now just pick one that you think you pretty much know is correct. And then just pick any of these numbers. So I'm just going to try this number because it looks the easiest. So W in this problem is $4. And the D was $5.25. minus $1.25. Let's see if that works out. $5.25 minus $1.25. 0, 0, bring your decimal. Oh, look, it worked. It is $4. So J is your answer. So 1, you save time having to work out every single one. You eliminated answers that made no sense, and you only actually had to test one of them to see if it was right. Okay, this is a Griddle Bolt from last year's STAAR test. So I just wanted to go over it to make sure you understood how the Griddle Bolt works. So before Nina bought groceries on April 22nd, she had a balance of $487.25. So a balance means that's the money she has in her checking account. Nina wrote her transactions in her check register. She included all her transactions through the end of the day, April 23rd. Based on the transactions in Nina's check register, what is the balance in dollars and cents in her checking account at the end of the day on April 23rd? Okay, so the first thing we have to remember is deposit. That's a plus thing. You're putting money in, you're depositing. Withdraw, that's a negative thing. You're taking money out. So, first thing we can do is work the problem. So we have $487.25. You are taking out $72.50. So remember, when you're adding or subtracting decimals, we line it up. 5 minus 0 is 5. We're going to need to borrow, make this 6, 12. 12 minus 5 is 7. 6 minus 2 is 4. 1, 4. But you're not done. It says after this day. So you did this one, check. Now go back, and now we have to deposit $15 in. So now we're going to add $15, which will give us $429.75. And it's positive because she has that money. So not only do you need to write the numbers in the box, but also make sure you bubble in. Your teachers will go over this with you on the day of the test, but just as a quick reminder, just make sure you bubble in. And this money is positive. Don't forget to put that plus sign, that it's a positive amount. The bubbles are what get scanned, so make sure you fill in the bubbles. Okay, this will be the last problem unless someone sends me any more that you have any questions on. Feel free to do that on Remind or on Google Classroom or email. So Hector surveyed all the 6th graders at his school, about their favorite after-school activity. The table shows the results were used to make a bar graph. Which percentage bar graph best represents this data? Well, the first thing I notice is that this says number of students. This does not say percent. So it's not a percent. It will tell you if it's a percent. The next thing I would do is actually look at your answer choices. Are there any that do not make sense? Well, the first thing I notice is that this one is 25%. This one's 25%. This one's 25%, and this one. They're all the same. You can look and kind of see just by looking at the bar that they're the same. But are these all the same? No, only 2 of them are, video games and sports. So I know this cannot be right. So that could be your throw out. Next thing you might want to look for is that your video games and your sports look the same. So in the other 3, I would say they do. So the next thing I would notice is which category will help me figure out the answer. So sports looks different in B and C. This one's smaller, this one's a little bigger, but this sports and this sports look really close to being the same. So honestly, I would pick reading because you can estimate this is about 15%, this is exactly 20%, and this is just a little more than 10%. So these 3 are different. So if I pick reading, I can tell which one is correct. Use your answers to help you answer the question. So the first thing you should think, if I have to find a percent, I should be thinking part to whole equals percent out of 100. So let's make a fraction out of these. So I'm going to use my part. It's going to be 44 in this problem. And the whole we're going to have to add to figure out what it is. So if I have 44 plus 55, that gives me 99. Check, check, did those 2. Plus another 55. That'll give me 154, check. Plus the 66. That gives me 220. So my whole is 220. So if you can't think of how to get from 220 to 100, remember you can also do a percent by changing it to a decimal. Remember FDP. So that might be the best case in this scenario. Remember, numerator goes on the inside, so 44, 220. Add your decimal. 220 cannot go into 44, put a 0 there. 220 will go in there twice, which actually gives you 440 exactly, because 2 times 0 is 0, 2 times 2 is 4. So you get 2/10, which we know in a decimal we have to move it twice, so that's 20%. Well, this one says reading is less than 20, so it can't be that one. This one says reading is 20, and this one says reading is less than 20. So look, just pick one. Don't try them all. Can you test them all? Go for it. But if you're running out of time, just find the one that's different and test it. Okay, well that's it. Hopefully this might be the last video for tonight. But remember, you got this, no worries. But if you do need anything, you know how to get a hold of me. Email, Google Classroom, Remind, and I'll answer any questions.